difference between these two voltage vectors, the relay knows that the feeder is healthy and does not operate. Let's now add a fault on the feeder. This must be a solidly connected system, as the current direction has reversed on NB, and both ends feed the fault. The single-phase voltage vector generated by end A is now different in magnitude and phase angle to the single-phase voltage vector generated by end B. Both of the differential feeder protection relays now measure this difference and operate, sending a trip signal to their associated circuit breakers. The fault has now been removed from the system.
So that's how it works. So let me shift back to my screen. Mana. Okay. So, okay. Let me activate the pointer. Okay, so let's move to the next topics right now. So let's see how does the pilot's protection scheme apply to multiple terminals line. So for multiple terminals line, which means that more than one transmission line to be protected. So as you can see by looking into these figures here, the transmission line is connected with more than two substations. So we have 1, 2 line in between this line networks here. So under this situation, if we have multiple terminals line, pilot's relaying system here will be the way where we can able to protect 100% of the line instantaneously, which means that occurs anywhere within the system. If you apply pilot's relaying system, it's able to clear the fault. But if let's say there's no outfit fault, or I should say there's no escape fault from any terminus, so the preferable scheme to be applied would be directional comparison scheme. All right, so now let's see the problems that we need to consider if we want to apply the pilot's protection scheme for multiple terminals line, which is this case. As being mentioned, the issue is actually the outfit fault. So in the event if there is an escape fault from one terminal to the another terminus, so it might cause the fault detectors rate at each terminus here, whether with directional feature or not, to activate the carriers, right? Which means that the tripping relay will not being prevent to trip, so that the external fault will actually cause the mount tripping occurs. So to solve these problems, we have two solutions. First, if let's say we are using distance protection for the multiple terminal line, so there's a need to implement a proper time coordinations between the relay in terms of setting the time delay for the zone 1 and the zone 2 protections. So we have to ensure that the zone 2 will wait for the zone 1 relay to trip the associate breaker first if we have the outfit faults. So under these situations, we can eliminate the multiple terminal line configurations and normal operations can be resumed. And the other solutions will be using the phase comparisons relay. Why? Because its operation is actually immune to outfit during both loads as well as external fault conditions. So basically, it will not affect its operations. But if we are using this scheme, right, the setting, or I should say the setting criteria, if we have 3 terminals configuration is extremely stringent. So we have to be properly set the pickup value for relay at each of the terminals. So it's best with equal contributions for all terminals in the case if we have external fault. So with such setting, each terminal will see twice as much of the fault current as comparing to the other two terminals here within the line. So here explain why the blocking signal is unable to be sent in the event if we have external fault. So let's consider these figures here for explanations. So now we have terminal 1, 2, 3. This is the line that we want to protect. And now we have external fault occurs outside terminal 3. And this fault current value, for example, is 125 amp. Alright, so during the first half cycles, this terminal 3 is actually with larger fault current, right, which is at 125 amp. So C outside, so it sends external fault. So which means that this terminal 3 will send blocking signal to terminal 1 and terminal 2. So this indicates that we have no issue. But at the other half cycles, right, now these two terminals must send the blocking signal to stop the operation for the relay at terminal 3 or at terminals 1 here. But right now, because of these configurations, so because it's split into two, so we know that this fault current is actually 62.5 at both terminals 1 and 2. So if let's say we do the tuning for the relay here, just set with the relay with larger contribution. For example, if you have the pickup here to be at 125 amp, so which means that if you have terminals 1 and terminal 2 here with the pickup current set at 100 amp, so basically it will not send the blocking signal. Why? Because it just sends this value here at 62.5. So it's under the pickup current value. So which means that these two terminals doesn't have large fault currents enough to send the blocking signal to the another side. So as a result, we will have false tripping occur even though we have external fault. All right. So the solution to these problems here is to double up the tripping level. All right. So that is basically how we deal with the multiple terminal slide. So research, we are reaching the ends of these chapters. All right, so we have looked into the problems of the non-pulse protection scheme. So basically, we know that the fault occurs at each end of the line, which is beginning and the last 20% here unable to clear instantaneously, seeing as we are relying on the backup protections. And then there are two operations modes possible if we are using pulse protection scheme. One is not blocking modes of operations. Another one is tripping modes operations. Blocking modes whereby is the signal sent over to the another side to stop the breakers from tripping. Tripping modes operations whereby right now the signal is actually communicate to another side and ask the breaker at the other side to trip instead. Okay, and then we also have talked about different communication channel you can use, including power line carrier, microwave system, fiber optics, and the power line telephones line, which is the pilot cables. And then for the link systems here, we have also talked about the directional comparison scheme, whereby you can have it as tripping modes or blocking mode. Then we have phase comparison scheme, whereby right now the phase angle of the metric current at both ends need to be compare. If let's say we have the internal fault, you will notice that the phase angles measured at both ends is out of phase by 180 degrees. If let's say external fault or fault free, they will be in phase at both ends. And then we also have current differential protection scheme to be used. And then we also talk about how actually we can implement the pulse protection scheme for multiple terminals line as well, whereby we have to focus on the upfit fault. Okay, so the setting criteria will be very strict if we are having the pulse protection scheme to multiple terminal, like if let's say we are using phase comparison scheme. So research, we have finished everything. So do you have any problems right now? So I noticed that there's no response. Probably some of you might be structuring for the FYP. So I will count to 5. If let's say there's no response, I will end the class. So 1, 2, 3, 4, 5. All right. Thanks for your attention and see you all this Wednesday for the tutorial.